All right, let's talk about artificial general intelligence, AGI. It's a term that gets thrown around everywhere, right? But what does it actually mean? Today, we're going to cut through all that confusion and explore a really powerful new idea that could completely change how we think about the difference between a super advanced tool and a true independent agent. Let's dive in.
So this is really the heart of the problem. You've got researchers, you've got journalists, you've got tech CEOs. Everyone's talking about AGI. But as our source material points out, nobody can really agree on what it is. And look, this isn't just an argument over words. When the definition is this shaky, it leads to some really muddled thinking and flawed debates about what's coming next. So today, we're going to try and bring some real clarity to this.
So here's our game plan. First, we'll tackle the AGI definition mess head-on. Then we'll get into a crucial idea. Being good at stuff isn't the same as being an agent. After that, we'll introduce a new concept called the continuity condition, figure out how to actually test for it, and then finally, we'll see why making this distinction is so incredibly important.
Okay, let's start with the mess itself. The big issue, as the source puts it, is this definitional instability. There's just no solid ground to stand on. And this creates a really easy trap to fall into, something called conceptual drift. Basically, we see an AI do something amazing, and our brains just leap to the conclusion that it must be a thinking, independent agent. We overinterpret its performance.
I mean, just look at how people try to define AGI. It's all about performance, right? It's about what the system does. It can perform like a human, it can adapt, it can achieve goals. And don't get me wrong, that's all super important for building these things, but it tells you absolutely nothing about what the system is at its core.
And that right there brings us to the single most important idea we're going to explore today. Just because a system is ridiculously good at what it does, I mean, even way better than any human, that does not make it a true agent. You see, being really good at something is just not the same as being something.
Let's put these two ideas side by side. On the left, you've got general competence. It's all about results, solving problems, succeeding at tasks. It's measured by performance. But on the right, that's what our source calls governance-relevant agency. And that is a much higher bar. This isn't about what it can do, it's about what it is. It's a unified self that lasts over time, something that can actually hold responsibility. It's defined by its very structure, not just its skills.
Okay, so if competence isn't the yardstick, then what is? How do we draw the line? Well, this is where our source proposes a brand new threshold, a real test to figure out if we're dealing with a tool or a true agent. It's called the ontological continuity condition. Let's break that down.
The whole thing really boils down to its history. A true agent has a past, and that past is an essential part of its identity. You can't just pause it, make a perfect copy, and say it's the same one. Why? Because its unique journey through time is what makes it, well, it. This idea of being non-interchangeable, that's the piece that's missing from almost every conversation about AGI.
Here's a really simple way to get your head around this. Think about your coffee machine. If it breaks, you can just buy the exact same model, and functionally, nothing is lost. It's interchangeable. But now think about your dog. You can't just replace your dog with an identical clone and pretend it's the same dog, right? Its unique memories, its experiences, that's what makes it who it is. The reset test is just asking, is this AI more like the coffee machine or more like the dog?
Now, this ontological continuity condition, or OCC, isn't just some vague philosophical idea. It's actually a concrete three-part test. For any system to be considered a true agent, it has to pass all three of these conditions.
So let's run through them. First is diachronic constraint. That's just a fancy way of saying its past choices have to truly influence its future choices, not just as data points, but as real commitments. Second, non-interchangeability. We've talked about this one. A perfect copy isn't a replacement, it's a new being. And third, self-maintaining arbitration. This means it has to sort out its own internal conflicts to stay true to itself, instead of just having a developer come in and patch the code. And this quote from the source just hits the nail on the head. Every AI system we have today, from the simplest algorithm to the most powerful large language models, fails this test. Period. You can restart them, you can copy them, that's what forkable means, and you can fix their mistakes from the outside. Their identity is just code and data. You can back it up, you can restore it. They are all, in essence, coffee machines.
So you might be thinking, okay, this is interesting, but it's all getting a bit academic, right?
Who really cares? Well, it turns out this distinction has massive real-world consequences. It affects how we govern these systems, how we regulate them, and most importantly, who's responsible when things go wrong.
First and foremost, it draws a bright, clear line between the tool and the author. If an AI doesn't pass this continuity test, then no matter how sophisticated it is, it's an instrument. It's like a hyper-advanced paintbrush or word processor. It is not the creator of what it produces. The human using it is.
This also helps us understand a really critical difference in how we interact with these systems. Look, you can delegate a task to a tool. Hey, sort this spreadsheet, write code for this function. But you can only delegate true authority to an agent. Authority means making a binding decision, and only a true agent can actually bear that weight and be held accountable for it.
And that leads to the bottom line. If an AI is a tool, if it's not a true agent, then responsibility can never, ever stop with the AI. The buck always passes back to the humans, the people who designed it, the people who deployed it, the people who oversee it. The chain of accountability remains completely clear. So all of this leaves us with one final, really powerful question. As we build these systems that are getting more and more capable by the day, we have to keep asking ourselves, are we just getting better and better at building really impressive tools? Or are we, maybe without realizing it, crossing that hidden threshold and finally starting to build agents? The answer to that question is going to define our future.